Hello, my name is Sarah Keane and I am an advisor on the PDST Primary STEM team. I would like to welcome you to this evening's webinar on number sense. Throughout the webinar, I will be joined by my colleagues Emma Fitzpatrick and Paul Timmins. This webinar will also be available for viewing after our live broadcast. You'll find it in the STEM section of the PDST website. If you'd like to tweet us during our live broadcast, our Twitter handle and hashtag are on the slide. This webinar will be an interactive session. Our PDST Primary STEM team are on hand to answer any questions you may have during tonight's webinar. If you have any questions regarding the content of this webinar, the Ask a Question feature is shown on the slide. This feature is accessible via the speech bubble icon on the bottom right-hand corner of your screen. Please remember to include your email address on the form if asking a question, as our response will be sent to the email address you provide. The learning intentions for this webinar are as follows. Participants will explore how number sense relates to a competency with numbers that is based on understanding rather than being reliant on memorization or algorithms. Participants will develop an understanding of the importance of number sense being taught and developed with all pupils in the class. Finally, participants will examine how carefully crafted maths talk is a powerful teaching and learning strategy to develop number sense. Number sense is sometimes referred to as having a feel for numbers. It is underpinned by having an awareness of the relationships between numbers, which can then support pupils in their interpretation of new number problems. The need for pupils to understand, not just recall number facts, is reinforced in the Irish primary school mathematics curriculum, as is the need for pupils to recognise and create mathematical patterns and relationships. Number sense is gradually developed and is critically important to pupils' mathematical achievement. Unfortunately, traditional approaches and textbooks can move too quickly to addition and subtraction and may leave pupils with a very limited understanding of number and their relationships. Number sense is about having a competency with numbers that is based on understanding rather than reliant on memorization or algorithms. Emphasizing memorization at the expense of understanding can inhibit pupils' mathematical development. Although mathematical facts have a role to play in mathematical development, they should be learned in a way that promotes understanding and flexibility, thus ensuring a more efficient way to remember and recall than merely learning by rote. Number sense can be taught and developed with all pupils in the class. In this webinar, we will examine research which suggests that low achievers in mathematics are often low achievers not because they know less, but because they don't use numbers efficiently. Traditionally, there has been an over-reliance on trying to memorise methods rather than interacting with numbers flexibly. Carefully crafted maths talk is a powerful teaching and learning strategy to develop number sense. Pupils talking about their mathematical thinking and engaging in maths talk has been identified as significant in supporting the growth of pupils' mathematical knowledge across all strands of the curriculum. Maths talk supports the development of number sense by empowering pupils to solve problems accurately, efficiently and flexibly. By sharing and defending their solutions and strategies, pupils have the opportunity to collectively reason about numbers while building connections to key conceptual ideas in mathematics. I will now hand you over to my colleague Paul Timmins, who will take you through the next section.
Thank you, Sarah. We will now watch a short video where Joe Bowler, a British professor of mathematics education at Stanford University, shares research that has concluded that number sense is important for all pupils. While watching this video, we would like you to reflect on the following. Firstly, what are the implications that this research has for our teaching? And secondly, what is the relevance of pushing pupils for speedy answers?
So there are very few research studies, very, very few, that I had read and immediately thought the results were so powerful they needed to be blasted from the rooftops and everybody should know about them. But here's one. Two British professors, Eddie Gray and David Tall, worked with 72 students between the ages of 7 and 13, and they had asked teachers to nominate students they thought of as above average, average, and below average. They then gave the students various addition and subtraction problems to do, and they categorised their strategies. For example, they gave them problems such as 7 plus 18, which is the addition of a single-digit number to a teen-digit number, as you can see here. And what they found was that students used 4 different strategies when they worked on number problems. So the strategies were, some students counted all. So with 7 plus 18, they would say 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, and count up to 18. And then to add them, they would count them all again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and go on like that. The slightly more sophisticated strategy of counting on is when students would add up to 7 or to 18 and then continue on. So if they'd added 18, they would then say 19, 20, 21. Known facts was when students just knew what the number bonds, they just remembered them. And what they called derived facts, which I would call number sense, and which this whole session is about, was when students were able to break numbers apart and decompose and add them and use them flexibly. So, for example, they might say, with 8 plus 17, I'm going to take 8 plus 2 and make that into 10. Or they may break 17 into 15 plus 2 and then calculate 15 and 2 and 8. So they make the problems into easier addition problems. And the results from the 8-year-olds was stunning to me. So the above average students, 30% of them knew the numbers, they used facts, known facts. 61% of them used number sense, so they used the numbers flexibly. And 9% of them counted on. In the below average group, 6% of them used known facts, none of them used number sense. 72% of them counted on, and 22% counted all. And when they worked with the 10-year-olds, they found that the below average group were using the same number of known facts as the above average 8-year-olds, so they're sort of caught up on the number they remember over time. But still virtually no number sense, and instead they were continuing to count. So why is this finding so important? The researchers who did this study put it well. They concluded that the low achievers, so often thought of as slow learners, were actually not working more slowly, but they were learning a different form of mathematics. And what's more, the mathematics that the low achievers were learning was the more difficult form of mathematics. And low achievers also are often identified as low achieving in school, and the help that they then often get is more procedures, more emphasis on doing procedures very carefully, rather than being taught to use numbers flexibly, and that's probably the very, very last thing that they need.
As you have seen, this video highlights that there was a difference between the low and the high achieving students. The low achieving students used no number sense and relied on recalling and using standard methods even when it was difficult to do so. We will now take some time to look at ways in which we can provide children with opportunities to develop their number sense, starting with counting activities. A facility with counting provides a strong foundation for the development of number sense. Counting encourages pupils to count on and count back, which represents an important first step in mental calculation. At a more sophisticated level, bridging through 10 can be used to further develop number sense. The importance of flexibility in pupils' counting cannot be overemphasized. There are 3 basic approaches that help pupils develop this flexibility. Different starting points. Young pupils can typically recite the names of numbers in sequence as if reciting a rhyme. However, starting from a different number, for example, not starting from 0 or 1, requires an understanding of number relationships, not just recitation, and so can contribute to developing flexibility in counting. Counting backwards. While the forward counting sequence is typically familiar to most pupils, counting backwards can be more challenging and requires a more robust understanding of number relationships, thus contributing to the development of flexibility in counting. Bridging the 10 or the 5. Once pupils can securely count forwards to 5, then 10, it is important to count beyond the 5 or 10 in order to reinforce the idea that counting is continuous, does not stop at 10, and can start and stop at various numbers. Furthermore, crossing the 10 can be challenging for pupils, because what comes after 10 can be different to the word pattern that precedes it. For example, counting on from 17 to 23 requires pupils to change from counting using a teen pattern, 17, 18, and 19, to counting using a different format, 20, 21, 22, 23, etc. This challenge is particularly acute when crossing multiples of 10. Regular practice crossing the 10 from various starting points, both counting forwards and backwards, can also contribute to flexibility in counting. To maintain interest, counting sessions should have a lively pace and enthusiastic participation. Sessions should include 2 or 3 different short focused activities comprising of physical movement and both choral and individual responses. The PDST primary STEM team has compiled a list of counting activities which can be accessed on www.pdst.ie/earlymaths. We will now explore the 4 relationships of number sense in the junior classes. Teachers should be aware that none of the relationships can be developed in isolation. They must be developed concurrently and used in context through a variety of activities. These activities will incorporate more than one relationship. These relationships can be developed beginning with 5, then progressing to within 10, within 20, and within 100. The first relationship we will look at is subitizing. Young pupils have a remarkable skill. They can recognize quantities up to 6 instantly and without counting. This is known as subitizing. Subitizing can help pupils to build images for numbers, to visualize, and to learn number facts. Structured images like this also help pupils to begin to see numbers inside numbers, for instance, seeing 4 and 1 within 5. Here is a sample subitizing activity. Flash the dot pattern of 6 for a second. How many dots did you see? How did you see them? In the classroom, pupils could create their own dot pattern using counters or by tapping the pattern on the table or in the air. Have the pupils discuss their arrangements. How did you see the dot pattern? Did you see it more than one way? Include easy patterns at first and then add more dots as their confidence builds. The next relationship we will consider is 1 more, 1 less, 2 more, 2 less. Knowing a quantity without counting begins with knowing 1 more and 2 more, 1 less and 2 less. This will help pupils to develop good mental calculation strategies. Here is a sample activity. Give the pupils a card showing 5 dots. Ask pupils to show a set of counters that is 2 less than the set shown on the card. This can be repeated for other numbers. Pupils can also be encouraged to add numbers to the sets involved and take turns reading out the associated number sentence to their partner. Now I'll pass you over to Emma, who's going to take you through the remaining relationships of number sense in the junior classes.
Our next relationship is friendly numbers. The number 10 is the basis of our place value system and serves as a benchmark to which other numbers can be compared. 5 serves as an important benchmark for young pupils. It is helpful in developing relationships for numbers 1 to 10. 5 and 10 frames are common models for developing the use of anchors or benchmarks to 5 and 10. We will now explore some activities incorporating 5 frames. To introduce the pupils to the 5 frame, ask pupils what can they see. 5 empty boxes. Explain to the pupils that this is called a 5 frame. Discuss why they think it is called a 5 frame. Pupils will need lots of hands-on experience building numbers on 1 to 5 on the 5 frame to begin with. Here is a sample activity for combinations within 5 on the 5 frame. Ask the children how many dots, how many empty boxes, how many dots and empty boxes altogether. This can be repeated for all combinations within 5. This can also be extended to the 10 frame. Once the pupils are familiar with making and reading the patterns, we can progress this activity by allowing the pupils to glance quickly at the frame. Then cover the frame and repeat the activity. How many dots? How many empty boxes? How many dots and empty boxes altogether? This helps the pupils to move from the concrete to the pictorial stage. Our final relationship is part-part whole. Part-part whole is the ability to see a number as being made up of two or more parts. This will help pupils to compose and decompose numbers, which is fundamental to the development of mental addition and subtraction strategies. Here is a sample activity. Cuisenaire rods are sets of coloured rods of 10 lengths from 1 to 10 centimetres that can be used for teaching number concepts. This activity, called Making 5, is taken from Ready, Set, Go Maths. It enables pupils to find out a great range of combinations for each number within 10. The teacher introduces the process by demonstration. The teacher asks the pupil, or explains to the pupils, we are going to make a train for the number 5. We need a 5 rod to start us off. Now we want to find some rods that fit together to make 5 exactly. Who has an idea? The child matches the 5 train with a 3 and a 2. Let's see what we have. A 3 and a 2. Well done, they fit our 5 rod. We can say 5 is the same as 3 and 2. Who has another idea? The demonstration continues in this way until the pupils have discovered a number of possibilities. Over a period of time, they will explore trains for the numbers up to 10. As soon as the pupils have grasped the process for making trains, the approach changes from demonstration by teacher to practical activities in which pupils exercise choice and make decisions. Initially, they will simply talk about their ideas, and later they will record them. I will now hand you back to Sarah, who will discuss Maths Talk.
Thank you, Emma. Maths Talk can be a powerful teaching strategy to enable pupils to make sense of mathematics and communicate their ideas. It can provide a context for pupils to clarify their own thinking while investigating and applying the aforementioned 4-number relationships. The following video is taken from Sherry Parish's Number Talks publication. The teacher engages the pupils in Maths Talk to develop their understanding and use of number relationships. Consider the 4-number relationships we have just explored. Subitizing, 1 and 2 more, 1 and 2 less, friendly numbers, and part-part whole. Can you identify from the short video clip which relationships the pupils are developing through Maths Talk?
Oh, hi. Time's fun.
Remember not to yell out if you know. Okay. DJ, what did you see?
5.
5? What did you see, Jen?
5.
5? What about you, Alex?
5.
5? What did you see? Oh, did you see 5?
5.
Did somebody see it another way? Alex, how did you see 5?
If you add one more, that will make...
Right. Right. Christian?
No. If you add the bottom part, it will leave it different.
Oh, if all the bottom was filled in, it would be 10. How did you know, DJ, it was just 5? You said 5 also. How did you know it was 5?
The bottom is not filled in.
Okay, what about the top?
The top, they're all filled in.
They're all filled in. If the top is all filled in, how many is it? 5. Sounds like nobody had to count.
Because
you were able
5
to see
plus
that.
5 equals 10, but if you minus 5 from 10, you get 5.
Okay, because it was just 5, right? Okay. All right.
Twins.
Ready for another one? Say it out loud. Jocelyn, what did you see?
6.
Cece?
7.
What did you see, Arjun?
7. 7.
7.
7.
What did you
7.
see? 7?
7.
7? Tell me how you saw 7, Roden.
Because the top was filled in and 2 more would make 7.
Okay, how did you think about that? The top was filled in.
And 2 more would make 7.
So you knew that was how many?
5.
5?
2 more would make 7.
Did you say 5 and 2 is 7, or did you say 5, 6, 7?
Yeah. No, 5 and 2.
Did you think of it a different way?
If it's a 10 frame, then if you had one more, it would be 8. And if you had 2 more, it would be 10. If you took 3 away, it would be 7.
So you saw 3 were missing and you knew that it was 7? Okay. All right. Let's do one more of those. If you know, put your thumb up. Priya, what did you see? You saw 10? Alex, what did you see? What did you see, Makai? 9, 6. Oh, I had lots of different numbers that time. Tell me what you were seeing, DJ.
Because both of those are the same.
They are. They look the same, don't they?
And it's more because I have 2 of them.
Okay. Show me how you found 6.
Because if you have one like that right there, it would be 7.
It would? Show me. 10. You want to change your guess? Lacey, how did you figure it out?
I counted in my head.
You did? Did you start over here and just count them fast? You did? Did anybody else see it a different way? Braden, what did you notice?
I've seen 5s on that for a long time, so I knew it was 5 and 5 make 10.
Okay, so you recognize that that was 5?
Yes.
Where have you seen that's 5? How do you know that that's 5?
Because I've played lots of games before at my house.
What kind of games?
Like Yahtzee games and stuff like that.
Okay, and so where do you see these dots like this that make
When
5?
I get a 5
On what?
on the dice.
On the dice. Okay, so you recognize that on the dice was 5 and that was 5 and you already knew that 5 and 5 was 10? Okay, you ready for another one? Ready? Are you ready? Micaiah, what did you get? 5? Okay, what did you get?
5.
5?
5.
Sounds like lots of people guess 5. 5. Priya, can you show me how you saw 5?
I can.
You counted them? Okay. Your head, you counted them. DJ?
If you had one more right there, it would be more than 5.
Okay, if you had one more right there, what would it be?
6.
6. So it almost looked like 6, but it was missing 1? Did you see that too, Christian?
5. If you add 2 more, that will make 7.
Yes, you're right. You recognize that. John Matthew, did you recognize that? How did you know?
Because I've seen 4 like that on a dice.
Oh, well, come show us what you mean by you've seen 4. Where's 4?
Right there.
Oh, okay, go sit down so I can show everybody what you mean. He said he saw this part that looked like 4 on a dice. And then what did you do? So you said 4.
And then I put 1 more and that would make 5.
And that would make 5. Good job. 4 and 1 more would make 5. Is that what you saw too, Braden?
No, if you put 1 in the middle, that means I would know it looks 5.
Oh, so if you move this dot down here, that would be 5? Okay. That was another good way of looking at that. If you moved a dot, you could kind of do that in your head, couldn't you? Okay.
As you've just seen in this video, it is important to consider the classroom climate before engaging in maths talk. The teacher should create a safe space where mistakes are inspected, respected and expected. Uncomfortable moments may occur as pupils productively struggle to make connections and verbalise their understanding of the mathematical relationships. These interactions promote confidence in pupils to communicate their mathematical ideas and develop conceptual understanding. We will now hear from 2 teachers discussing the benefits of maths talk. These teachers collaboratively planned a team teaching programme to develop number sense with their pupils.
There are a lot of benefits to using number talks. I've noticed in the past few months that we've been doing it that the children's sense of number has improved. They're much more confident manipulating number, and they're very confident in terms of speaking out and saying, I use this strategy, it might be different to my friend and that's okay. And I feel like they're really enjoying learning from each other. And I also feel that they have a growing awareness that there are different ways to arrive at a number. There's not always one way, and that's a good thing. and they are putting more and more emphasis on the process and not just the product, which I think is really, really important. And in terms of the different groups in the class, I feel the lower attaining students, I feel, have really come along, because I feel we put a lot of emphasis on using concrete materials in the beginning, like the rec and the 10 frames, and so those children were able to visualise the number and the operations before moving on to the concrete and the abstract. So I feel that's really, really helped them and boosted their self-esteem. And I feel for the higher attainers, it's really helped them as well, because and in the beginning they found it quite difficult to explain how they got to their answer. There was a sort of level of automaticity to it, but they couldn't explain it. So it sort of challenged them to explain, this is how I got there, and to give them an awareness that there are more ways than one to get to an answer, and it's giving them a range of strategies. And I feel that that's pushing them along in terms of their mathematical flexibility.
Yes, I'd agree wholeheartedly. And I think also that the way it's organised, I love the number talk time, as I think the children do. And the way it's organised, where the children actually come up and sit in a little circle at the front, it's almost not a teacher teaching session. It's rather a sharing of knowledge and skills, and that is in effect what it turns out to be. And I like the way that you sometimes ask them to consider a second strategy and a third strategy, and I think that really challenges the higher attaining pupils who would have been the ones with their hands shot up with the correct answer very, very quickly in previous times. I like the way they just indicate how many strategies, and they're challenged to think of a few different ways. And in effect, I suppose it's good for them also to be thinking there's not just one way to approach this problem. And I certainly think that the children who maybe struggle a little, the lower attaining, do actually learn from the others.
They do, absolutely.
They really do.
Absolutely. And I think number talks are, designed to allow that environment of discussion and openness and kind of create a culture of learning from each other. I think that's the most positive benefit.
The children are quite used to volunteering answers in the safe, secure knowledge that every answer is legitimate. And one of the nice things about the number talks is that we're not looking for the right answer as such. We're looking for how you came about your answer. And the children know that they can volunteer their answers, they can defend their answers, explain what strategies they used, and it's very interesting sometimes to actually see them on the go self-assessing, so that a child sometimes comes up with the incorrect answer, but in defending it and retracing their steps actually discovers where they went wrong. And that's certainly, as a learning support teacher, that's a joy to see.
It's lovely to see.
It enhances their self-esteem, and it gives them an opportunity to self-assess, as well as, of course, teacher assessing as well.
As those two teachers discussed, number sense is for all pupils in the class. Paul will now talk you through the key messages that we explored in tonight's webinar.
Thanks, Sarah. In this webinar, we have focused on introducing teachers to the importance of developing number sense with their pupils. We explored counting as the foundation of number sense and the 4 important number relationships: subitizing, 1 more, 2 more, 1 less, 2 less, part whole, and friendly numbers. We also delved into how maths talk can support the development of number sense. Before we take questions, we want to reiterate the many supports available to schools in the area of mathematics. This webinar has offered teachers an introduction to number sense. PDST primary STEM advisors are available to further support teachers and schools with developing pupils' number sense through school support. If schools apply for sustained support, they may receive a series of visits from an advisor to create a shared vision and timeline for teacher CPD within the school's own context. Principals can apply for this support on the PDST website, and in order to apply, you will need the school roll number. The password for application this year is School Support 2019. The primary STEM team has published a number of resources to support teachers in engaging pupils in rich mathematical experiences across the curriculum. PDST mathematics handbooks and resources are available on the PDST website and can be downloaded for free. Schoolnet.ie is the Department of Education and Skills official portal for Irish education. Schoolnet.ie collaborates with practicing primary and post-primary teachers to maintain and manage the content on the website. Teachers have the option to upload and share their own resources to the site. Now I'll pass you back to Emma.
Thank you very much, Paul, and we'd like to thank you all for engaging with tonight's webinar. We would like to thank our colleagues in the webinar studio, particularly Sean Dower, for all his assistance in creating this webinar. We would also like to express our gratitude for the invaluable advice from our colleagues on the primary STEM team, in particular Orla Byrne, Roisin McGovern and Anne Tracy, as well as the PDST Digital Technologies team. We will now address some of the questions asked during the webinar. So our first question is number sense just the concern of the teachers in the junior classes, and what class can Maths Talk be used in? So Sarah, maybe you'd like to take that one?
Well, I suppose number sense is for all pupils, as Jo Bowler referred to in her video. Rather than just learning off facts, it is about developing understanding and pupils being flexible with numbers. As you've seen in the videos as well, especially from the Irish teachers talking, Maths Talk can definitely be used for all pupils from junior infants to 6th class, and it's not confined to just number, it can be used to all the strands in the maths curriculum.
Thanks, Sarah.
The next question we have here, what resources would you suggest to use to get started with number sense in my classroom? Emma, can you offer any suggestions?
Well, luckily many of the resources that we need for number sense we already have in our classroom. So things like counters, dice, playing cards, numeral cards and 100 squares. These are all things that usually are found in our classroom. You may also need to make or purchase some other items like dot patterns, the 5 and 10 frames that we've seen in our webinar, bead strings and reckon racks are a few that come to mind. So, Paul, I have a question here for you. What activities can assist the development of early number sense?
Thanks, Emma. Well, I suppose the use of concrete materials and games can be incredibly useful for reinforcing and developing number sense. Our own website, as well as the websites such as Enrich Maths and NZ Maths, offer a variety of interesting activities and games for teachers to use with their classes. And we'll put the links to these on our Twitter account now for teachers to access. Okay, the final question we have here this evening is, how can number sense be differentiated in a multi-grade class? And Sarah, you might take this one.
Thanks, Paul. I suppose as we referred to earlier, number sense can be used in all classes, and we've seen that in the videos, especially from the 2 Irish teachers speaking from their perspective. So number sense does lend itself nicely to differentiation and can most definitely be used in a multi-grade class. We spoke earlier about counting activities, but these don't have to be just confined to the junior classes. For example, older pupils could benefit from counting in fractions, decimals, percentages, or even 5-minute intervals on the clock, for example.
And just leading on from that, Sarah, as Paul mentioned earlier, we have the PDST handbooks, so the mental maths and place value manuals in particular offer a range of ideas around that area. And also, if schools apply for sustained support, an advisor is on site to create a bespoke package around number sense within the school's own context along with the staff. So thank you for listening to us tonight, and just once again to remind you that this webinar will be available on the STEM section of the PDST website.